All right, let's do another example of finding a limit. So this is going to be similar, right? I told you that these were sketchy because you had to like really be paying attention. So here's a limit x and y tending to 0, 0 of x squared y over x squared plus y squared. Does this look any different really from the one we just did? Yeah, I mean, if I hadn't had that other one right in the back, like, if we hadn't seen the other one 2 minutes ago, right? This would be, yeah, man, that's the exact same thing, right? I mean, there's a y in this one that there wasn't in the previous. But this is what I was talking about, they're subtle. Yeah. So let's try along a couple of paths, and then we'll see if we can maybe sort this a different way. So what are your two favorite paths going to be?
X-axis and y-axis.
X-axis, y-axis, right? So let me just kind of off the side, right? Okay, so along x is 0, this is the limit x and y, 0 and y tending to 0, 0 of what's your function going to be?
0 over y.
0 over y squared, that's going to give me 0, right? Okay. What if I do y is 0? Do limit x and 0 going to 0, 0 of 0 gives me 0. Okay, have I established that this definitely exists?
No.
Yeah.
No.
Oh.
You have to do like a bunch of pathways.
Yeah, you have to do all the possible pathways, which takes forever. Okay? Literally forever. That process is not going to end. So if you've tried a few pathways, like maybe let's try one more, just for kicks. Okay, let's try y is x for kicks. We've got the limit x and x tending to 0, 0 of what? X cubed over 2x squared gives you x over 2. And as I send x to 0 for x over 2, what do you get? 0. Okay, so I tested 3 paths now. Okay? All right, you guys ready for this?
Pretty sure it's continuous.
All right, so let's see. I'm supposing that this limit's probably 0, right? You guys see that? Okay, so I'm going to just look at, let me see how far this thing is from 0. So I'm going to take, oh, I'm sorry, I don't want to do that. I want to plug it. Okay. I'm going to test how far that is from 0. So I'm going to take that thing, x squared y over x squared plus y squared. And I'm going to subtract my supposed limit. You guys see this? And I'm going to see if I can force this quantity to be small by making x and y close to 0, 0. You guys see that? If I can do that, then I'll be set. I'll know that this limit works and is 0. Okay, so do I need the minus 0 on this?
No.
Nah. Okay, so I've got the absolute value of x squared y over x squared plus y squared. Okay, so now let's do the totally obvious step. Maybe not totally obvious. Of saying this is the absolute value of x squared over x squared plus y squared times the absolute value of y. Right? Okay. How big is this thing? Yeah, I want to make this quantity small, right?
Yeah.
I want to see that this thing is close to its supposed limit. So how big is this piece?
Really big. Too big.
Big, small, approximately.
Really small. I don't think so.
Are you
Or
referring to
just
the denominator or
the
y?
whole thing?
Sorry, this whole piece.
Oh, so it's really
Oh.
small on this whole piece.
remember, I'm sending both x and y to 0, right?
Yeah.
So this thing, right? Ballpark is how big?
Zero.
Bigger than 0.
I would like to say that it's 0 over. Oh, but I have to send both of them to 0, right?
Oh.
So it'd be 0 over 0.
So I'm looking at this thing and I'm thinking that's probably like 0 over 0, right?
So that
But
goes-
what's bigger, the top or the bottom?
Bottom.
Bottom's definitely bigger, right?
Yeah.
So this thing, right, whatever the heck it is definitely smaller than 1.
Yeah.
You see that? And now as I send x and y to 0, what's going to happen to the absolute value of y? It's going to go to 0, right? So I know that I could write this statement. I could write as x and y tends to 0, 0.
Sorry, it
What?
looks really familiar now.
Yeah, it
And
should.
that's unfortunate.
It's okay, we're not going to do too many of these because they're extremely complicated. So, as x and y tends to 0, 0, what?
Approaches 0.
Yeah, this thing, right? X squared y over x squared plus y squared tends to 0. Y. You need the because, right?
It's less than something we know tends to 0.
Because of that stuff. Right? You guys see this? So what we're thinking, right, is we're going to take the distance, right? This thing here is f of x and y minus L, right? I'm taking how far is f of x and y from L, and I'm controlling it with something to do with how close x and y is to 0, 0. You guys see that?
Does this have anything to do with like the convergence tests?
Yeah.
Where if it's
Yeah.
less than 1, it converges. If it's 1, it tells us nothing. If it's greater, it
This
diverges.
has more to do with what a series converges to,
Okay.
right? That's a limit idea too.
It's the limit comparison one. Is that why you don't drop the absolute value signs around the y and it's still a variable? Like where if you had ends, you would.
Yeah.
But
Yeah, and you can approach from left and top and bottom and left.
Yeah, it's actually nice for me that this has an absolute value on it because I'm going to send y to 0. I don't know what that is. So I'm going to send y to 0, right? And then that controls this absolute value of y,
yeah.
which controls this thing.
Okay.
You guys see that? Cool? Questions, thanks? In fact, here, I don't even need to send x to 0. Do you guys see that?
Yeah.
It's the same.
This thing's always smaller than 1, right?
Yeah.
So anytime I send y to 0, this quantity goes to 0. So I got a little bit more, right? I got the limit as whatever in y goes to whatever in 0, right? Cool? Questions, thanks?